Hello everyone, welcome back to my channel. Today's topic is a problem set on the capital asset pricing model or CAPM, one of the most important concepts in financial economics. If you are a student of finance or economics, there is something you definitely need to understand. This content is based on the book Mathematical Financial Economics, Basic Introduction, specifically from chapter 10, Problems and Exercises. Today we will not only understand the theory but also focus on solving problems step by step. Now, before we dive into the problem, let me briefly introduce myself. I am Sundevan Shobhan, currently pursuing my master's at Shahjalan University of Science and Technology, Sylhet. Through this channel, I am to simplify complex economic and financial concepts for you. So, here is the CAPM based problem. Now, whenever you see a CAPM problem, you should immediately think about this key idea. So, what is the idea? CAPM helps us determine the expected return of an asset based on its risk relative to the market. The core formula behind CAPM is expected return equals to risk-free rate plus beta plus market return minus risk-free rate. So, in any problem, your job is to identify the risk-free rate, the market return, and the beta of the asset. So now let's have a look the problem. So the problem said that assuming that the market contains a risk-free asset with non-random return r greater than zero, find the solution x to the power mu to the following problem. Here we should to minimize the variance of the return rx on the portfolio x. And problem B stated that according to Tobin's mutual fund theorem, every efficient portfolio in particular X star mu is a combination of 1 minus gamma x to the power minimum plus gamma to the power v of the minimum variance portfolio. And you should look, here is given the formula, uh, gamma mu equals to mu minus r into a minus rc divided by h. Now go through for the solution. So first we identify the given values from the problem. This is crucial. Many students make mistakes here by missing small details. We carefully extract the risk-free rate, market return, beta. Then we plug these values into the CAPM model. So here you can see if mu greater less than or equal r, then the solution to the problem mu to the power m to the power mu is the portfolio E naught. Indeed, the return on E naught is r. So while the variance of return on this portfolio is zero, which an absolute minimum for events. Now let us assume that mu greater than r. So from the chapter 6, equation 6.1, we it was proved that the expected return on the X star tau efficient portfolio X star tau corresponding to the risk tolerance tau is given by the formula ER X to X star tau equals to R plus tau T tau by 2 into H. Consider that value of tau equals to tau mu, for which, in other words, tau equals to tau mu equal to, we can substitute value 2 into mu minus r divided by h. We have tau mu greater than 0 because mu greater than 0. Consider the efficient portfolio x star tau corresponding to the risk tolerance. We claim that this portfolio is the solution to optimization problem mu m to the power mu. Suppose the contrary, there is a normalized portfolio x with ERX greater than or equal mu, and variance Rx tau less than variance Rx star tau. But mu equals to e to the power e Rx tau star by virtue of the definition of tau equals to tau mu and the formula mu equals to r plus tau by t h for the expected return of the portfolio x star tau. Consequently, ERX greater than equal ERX star tau and variance RX less than or equal variance RX star tau. This implies tau e to the power e Rx minus variance Rx greater than tau e Rx star tau minus variance Rx star tau. Which means that x star t is not the solution to the optimization problem mu tau a contradiction. To compute the portfolio x star mu, solving the problem optimization problem m to the power mu, it remained to substitute tau equals to tau mu equals to 2 into mu minus r by h into the expression for x star t, x star tau obtained in chapter 5. Now have a look at the equation. Thus, the solution to the Markowitz problem mu to the power m to the power mu for the market with a risk-free asset is given by x star mu equals to 1 plus mu r into rc minus a divided by h and mu minus r into w into m minus re divided by h. So here we can see the problem solution number A. Now have a look the second solution. To find gamma equals to gamma mu for mu greater than r, we write x to the power star mu equals to 1 minus gamma into x to the power minima plus gamma v. Since v equals to w into m minus re divided by a minus rc, we obtain gamma into w into m minus re divided by a minus rc, which equals mu minus r into w into m minus re divided by h, which yields a gamma mu equals to mu minus r into a minus rc divided by h. So here is the solution number 2 or our B number question. So what did we learn today? CAPM is a simple but powerful tool that connects risk, market behavior, and expected return. And solving CAPM problems becomes very easy if you follow a structured step-by-step approach like just we did. Before you go, thank you very much for watching. If you found this video helpful, don't forget to like, share your thoughts in the comments, and most importantly, subscribe to the channel for more educational content like this. See you in the next video.